the first problem. The first problem is asking us to find V Thevenin and R Thevenin. All right. The different part about Thevenin is going to be that typically when we're finding our equivalent, we're working that way towards the source. But in R Thevenin, we're going to work towards OC. So open circuit, open terminals. So as before, how I said that imagine we went and dropped an imaginary wire here. We created a plus minus VOC. What we're going to do is to find our Thevenin, we're going to go through our steps. And here's our steps to solve. So write our steps. So step number 1 is going to be, are there any dependent sources? And take a look. I don't see any diamonds in there, so you say no. So we can move on to step 2 now. Step 2 is going to be 0 out sources. And this is where we're going to take the batteries, turn them into wires, or take current sources and turn them into open terminals. And if we look at our circuit, we have a current source. So if we go and redraw our circuit, we'll go and put everything where it belongs. It's R1, this will be R2. And then plus minus VOC. Okay, so now what we did was we just went here and replaced the current source with open terminals. And then we can move on to step 3, which is going to be to find R Thev, which is just equal to our equivalent with respect to the open circuit. Okay, that's our open circuit. So what we can do is something that's interesting is we can just treat this VOC as if it's a battery, and we can act as if current was to come up this way and go down through the circuit. What would it do? So we see that the current's going to come up through this way, pass through R2. It's going to hit this junction, and it's going to see it can go down through the resistance, or it can go left where there's an open current or open circuit, and we can't go down that way. So it will have to come this way. Once again, it can't go down through these open circuits, so it will come up and that way and repeat its loop. So we can essentially just say, okay, that part of the circuit does not exist for us, and we're just looking at this. So if we were to look at these two, this circuit on the right, we see that these two are in series. So I can go ahead and say R series 1 is going to be equal to R2 plus R1, which will give me 40 plus 10, which will give me 50 ohms. And if I was to go and redraw it one more time, and here, let's actually do it just for the sake of simplicity. We'll just stick with that. Okay. Put our imaginary wire here, act like that's a battery. And then this is our series 1. And on the right is the VOC. And now we notice we only have the one resistance value. So R series 1 is equal to R equivalent. And because we're trying to get it down to one resistor, that is our R Thevenin. So R Thevenin is going to be 50 ohms. Okay. So we found R Thev. Good. Now we need to find V Thevenin. So what we need to do is jump back to the original circuit. So for step 4, go back to original circuit. Like this. There we go. This is R2, this is R1. And then we have plus minus VOC. Okay, so if we look at our original circuit, we see that VOC, or here we'll do this, VOC isn't connected to anything. However, it's still in parallel with R1. So if we can find the voltage across R1, we can find V Thevenin. So let's look at what the current does. So here, the current will come this way, hit this junction, sees it can't go down the open branch, so it'll come through here, can't go down this open branch, and then travels up that way, and just creates a loop. So we can use V is equal to IR to find the voltage across R1. So step 5, find VThev. And to do that, we just have V is equal to I times R1, which is equal to the current running through it is 5 amps. The resistance value R1 is 10 ohms. So V of 1 is equal to 50 volts. And we can say VOC is parallel to VR1. Therefore, VOC is equal to 50 volts, which is equal to V Thevenin. And we have now found V Thevenin. All right, very simple example, a little bit more in-depth explanation, but you'll get the hang of it the more you practice it.